There's a star in tonight's sky that's been lying to us. Not metaphorically, literally lying about its size, its speed, its behavior, and possibly even whether it's alone. And for years, our best telescopes, our best physicists, our best models couldn't figure out why. We finally have an answer, and it's stranger than the explosion we've been waiting for. Look up at Orion on any clear night, and you'll see it immediately. That reddish smolder on his left shoulder, burning like an ember that refuses to go out. That's Betelgeuse, and it is enormous in a way that language struggles to contain. If you dropped it where our sun is right now, its surface would swallow Mercury, then Venus, then Earth, then Mars. It would be pushing toward Jupiter before it stopped expanding. This single star would erase our entire inner solar system without noticing. It is also dying, slowly, violently, inevitably, burning through the last reserves of fuel in its core, swelling and pulsing in its final chapter. When it finally collapses, it will release more energy in a fraction of a second than our sun will emit across its entire 10 billion year life. It will briefly outshine entire galaxies. It will be visible in broad daylight from Earth. And here's the part that should keep you up at night. We have no idea when. What we do know is that Betelgeuse has been acting wrong. For over a century, astronomers tracked what looked like a reliable rhythm, a stellar heartbeat. Every roughly 400 days, the star would brighten, then dim, then brighten again. Giant convection cells churning beneath the surface, like water boiling in a pot, except the pot is larger than Earth's entire orbit around the sun. Normal, understood, predictable. But hiding underneath that rhythm was a second pulse, ghostlier, longer. A faint, mysterious cycle that repeated every 2,170 days, just under 6 years. Nobody could explain it. Theories were floated and shot down. For decades, it sat in the data like an unsolved equation, a nagging cosmic question mark. Then, in late 2019, Betelgeuse stopped being subtle about its problems. It started fading. Not slightly, not in ways only instruments could detect. It faded so dramatically that amateur astronomers noticed it from their backyards. Orion's blazing shoulder, one of the most recognizable points of light in the night sky, grew visibly, unmistakably dim. It lost more than 2/3 of its normal brightness. The astronomy world erupted. Telescopes were scrambled. Emergency observing time was granted. The question burning through every research paper and every late-night conversation was the same. Is this it? Is Betelgeuse about to explode? When Hubble finally got a close look, the answer was both simpler and more disturbing than anyone expected. Betelgeuse had sneezed. Not figuratively. The star had launched a colossal eruption, a surface mass ejection that blasted a chunk of its own outer layers into space. That blob of superheated plasma traveled millions of miles, cooled, and condensed into a massive dust cloud that acted like a cosmic curtain drawn across the star's face. By April 2020, the curtain cleared. Betelgeuse returned to normal brightness. Mystery solved. Except, it wasn't. Not even close. The dust cloud explained what happened. It did nothing to explain why. What triggered an ejection that perfectly timed with the star's most dramatic dimming event ever recorded? And why did it still sink eerily with that unexplained 6-year cycle? The pieces were all on the table. None of them fit together. So scientists went deeper, and 2 suspects emerged. The first theory? Betelgeuse isn't alone. Finding a companion star next to something as blindingly bright as Betelgeuse is like trying to spot a firefly hovering next to a lighthouse. Nearly impossible. But the math was compelling. A companion star orbiting every 6 years would explain the mystery cycle almost perfectly. Its gravity, tugging rhythmically on Betelgeuse's bloated outer atmosphere, would create exactly the kind of ripples we've been observing. Regular fluctuations that have nothing to do with the star's internal behavior, but everything to do with an invisible partner dragging it in a slow gravitational waltz. And here's where it gets wilder. If that companion's orbit periodically carries it through a particularly dense region of Betelgeuse's atmosphere, imagine the timing of the Great Dimming, the gravitational nudge could have been precisely the destabilizing force needed to trigger the ejection. The companion star may have done what we couldn't. It bumped the table, and the whole thing collapsed. A hidden star, explaining the 6-year pulse, triggering the Great Dimming. With one solution, 2 of the biggest mysteries evaporate. But there's still the third mystery, and this one is even stranger. When a star expands into a red supergiant, basic physics demands it slow down. Think of an ice skater pulling their arms wide. Rotation drops. It's not a suggestion, it's conservation of angular momentum, fundamental, inviolable law. Yet measurements of Betelgeuse clocked it spinning at roughly 5 kilometers per second. For a star this size, that's not just fast, that's impossible. So astronomers proposed something violent. Maybe Betelgeuse ate another star. As it expanded, it engulfed a smaller companion, absorbing its orbital energy and spinning itself up in the process. It's a dramatic answer, stellar cannibalism as the explanation for an impossible speed. But then a newer theory emerged that reframed everything. What if the star isn't actually spinning that fast? Betelgeuse's surface is not solid. It is a churning, boiling chaos. Enormous gas bubbles the size of planets, rising and falling in slow, violent convection. Recent simulations showed something startling. If a massive bubble is rising on one side of the star, while another is simultaneously falling on the opposite side, the resulting light pattern is nearly identical to a fast rotating star. In over 90% of simulation runs, this turbulence fooled observers into reading rapid spin where there was only surface chaos. The impossible spin may be an illusion, not rotation, turbulence wearing rotation's mask. So what do we actually have? A star with a genuine 6-year mystery cycle, a catastrophic surface ejection in 2019 that nobody predicted, a rotation reading that may or may not be real, and a possible hidden companion lurking in the glare. Here's the picture that's slowly emerging. Betelgeuse is a deeply volatile star at the end of its life, its interior churning with convection cells that dwarf our entire solar system. A companion star, if it exists, orbits once every 6 years, its gravity periodically agitating that already unstable surface. In late 2019, the timing aligned. The companion's gravitational pull nudged a massive convection cell at precisely the wrong moment, launching the ejection, creating the dust cloud, dimming the star so dramatically that millions of people on Earth looked up at Orion and thought they might be watching a star die in real time. And the spin? The turbulence does all the work. No cannibalism required. The star is chaotic, not fast. But, and this is crucial, none of this is settled. Scientists are still fiercely debating whether the companion is real or a coincidence of data, whether the Great Dimming was triggered externally or internally, whether the 6-year cycle is gravitational or something deeper in the star's own physics that we don't yet understand. What we know for certain is this: Betelgeuse's fate is sealed regardless. It is a massive star. Its core will eventually collapse under its own gravity. The outer layers will rebound in a shockwave of unimaginable violence. And when it finally explodes, It will be bright enough to cast shadows at night, bright enough to see with your eyes at noon on a clear day. An astronomical event that no living human has ever witnessed. But the new complexity, the possible companion, the turbulent interior, the cascading interactions, means we now have more variables than ever before. The companion, if real, could accelerate or delay the collapse. Our margin for prediction has not shrunk, it has grown. The universe does this. Every time we think we've understood something, we find a deeper layer. Betelgeuse spent decades looking like a simple story, a dying giant waiting to explode, occasionally dimming, basically predictable. It wasn't. It's a dynamic system, hiding its most important behaviors behind its own blinding brilliance. A star that may have a secret, that may have triggered its own most dramatic event through the interference of an invisible partner, that may have been showing us for years what we weren't yet equipped to see. The next time you step outside on a clear night and find Orion, and you will find him, he's impossible to miss. Look at that reddish point of light on his shoulder. You're not looking at a dying star. You're looking at a cosmic cold case that we are, right now, finally beginning to crack. And at some point, tomorrow, a century from now, 100,000 years from now, it will close that case for us in the most spectacular way possible. If this one lit something up for you, subscribe, because we're going deeper every week into the mysteries the universe keeps trying to hide. And drop a comment. Do you think Betelgeuse has a hidden companion, or is it just the most turbulent solo act in the Milky Way? Let's figure this out together.